You have eaten both of them your entire life. Separately, your body handles them without complaint. But the moment they arrive in your body at the same time, sugar and fat, together, something starts that researchers only fully understood in the last decade. Something that reaches your brain before you finish the bite, your gut before the meal is over, your skin over the months that follow, and the deepest part of your sleep hours after the plate is cleared. Most people feel every part of this. Nobody ever showed them the sequence. Today, we are going inside, organ by organ, starting from the first swallow. Let's begin with something almost no one talks about. In nature, in whole foods, in anything your body evolved alongside, sugar and fat almost never appear together in high concentrations. Fruit carries sugar, almost no fat. Meat and nuts carry fat, almost no sugar. Milk is the rare exception, and even there, the concentrations are moderate and the delivery is slow. The foods that combine high sugar and high fat simultaneously, the ice cream, the croissant, the chocolate, the cookie, these are almost entirely modern inventions. Your digestive system has no blueprint for them, no calibrated off switch, no learned threshold that says, we have had enough of this particular combination. This is not a flaw in your character. It is a gap in your evolutionary programming. Researchers at the Max Planck Institute for Metabolism Research gave participants either a high sugar food, a high fat food, or the combination of both, and scanned their brains. The results were striking. Separately, each ingredient produced a predictable dopamine response. Together, the response was disproportionately larger, not the sum of the two effects, but something significantly beyond it. The researchers called it supraadditive, a reward signal your brain has no natural ceiling for because it never needed one. This combination simply did not exist in the environment you were designed for. Now let's follow what that signal actually does, because this is the part that changes everything. The moment sugar and fat reach your tongue together, two separate receptor pathways fire simultaneously and converge in a region of the brain called the striatum, the same region activated by nicotine, by alcohol, by gambling. Dopamine is released, but what makes the combination uniquely powerful is the timing. The dopamine does not wait for you to finish eating. It begins releasing in anticipation when you see the food, when you smell it, sometimes simply when you think about it. And it continues throughout the meal, creating a reward loop that runs longer than any whole food was ever designed to produce. Scientists using functional MRI found that participants consuming sugar-fat combinations showed prolonged activation in the orbitofrontal cortex, the part of the brain responsible for decision-making and the ability to stop. While that region is occupied processing reward, it is simultaneously less available for the thought that would normally intervene. You finish the piece. You reach for another, not because you are hungry, because the loop is still open. And here is where the story gets personal, because the loop does not close when the meal ends. 2 to 3 hours later, blood glucose begins to fall. The insulin released to manage the earlier spike is still circulating, and with less glucose arriving, it pulls blood sugar past the baseline. This is reactive hypoglycemia. It produces a specific and recognizable set of sensations: fatigue, mental fog, irritability, and a craving, urgent, focused, for something sweet or starchy. At the same moment, the dopamine that flooded your reward center during the meal has receded, and your brain registers its absence the way it registers any withdrawal: flatness. A pullback toward the thing that made it feel the way it felt. The craving you experienced 2 hours after dessert is not hunger. It is your nervous system trying to reopen a loop it just felt close. And if this repeats, if the combination is a daily feature of your diet, the brain begins a deeper adaptation. Dopamine receptors downregulate. The same amount of food produces less reward. More is required to reach the same effect. Research published in Food Science and Nutrition and supported by neuroimaging studies across multiple institutions documents this clearly. People who consume high-fat, high-sugar foods regularly show a measurably reduced dopamine response to those same foods over time. It is the identical adaptation pattern observed in chronic drug exposure. Tolerance accumulating quietly through something you ate after dinner. But this is only the beginning of what that meal is doing. Further down, in your gut, a different process is unfolding. Fat slows gastric emptying significantly. The stomach holds the combination longer before releasing it into the small intestine. This extends the glucose curve. Instead of a sharp rise and fall, you get a prolonged elevation. The pancreas continues secreting insulin, and because the caloric load of a typical sugar-fat meal is substantial, insulin directs the surplus first to muscle and liver tissue. Then, when those stores are full, to fat cells, through a process called lipogenesis. The fat you ate is stored, the converted sugar is stored. Both from the same meal at the same time. Simultaneously, your gut microbiome registers the combination as a disturbance. High sugar suppresses beneficial lactobacillus populations. High saturated fat promotes the growth of bacteria linked to low-grade systemic inflammation. The combination shifts your microbiome in ways researchers now connect directly to mood disruption, through the gut-brain axis, and to skin inflammation, through the inflammatory signals that travel in your bloodstream. Which brings us to the surface, and to the part that most people find the most surprising. Your skin records what you eat. Not immediately, slowly, over months, in a protein called collagen. Collagen is the structural scaffold that keeps skin firm and elastic. But when blood glucose remains elevated repeatedly, glucose molecules begin attaching to collagen fibers in a process called glycation, forming compounds called advanced glycation end products, AGEs. Research published in experimental dermatology confirmed that regular consumption of high sugar and ultra-processed foods directly raises systemic AG levels. These compounds cause collagen fibers to cross-link and stiffen, losing their elasticity. The result is skin that ages from the inside, not from sun exposure, not from dryness, but from what arrived in your bloodstream every evening for years. No topical product reaches this. The process is happening below the dermis. Now, here is the part most people never connect. What happens at night? If the sugar-fat combination was eaten in the afternoon or at dinner, it has not finished with you by the time you fall asleep. Insulin and melatonin, the hormone that prepares your body for sleep, compete for overlapping receptor pathways. Elevated evening blood glucose suppresses melatonin onset, delaying your body's sleep preparation signal. Research from Massachusetts General Hospital and the University of Murcia confirmed that high carbohydrate and high fat intake in the evening impairs blood glucose regulation through a defect in insulin secretion, and this effect is amplified in roughly half the population due to a common genetic variant in the melatonin receptor. Then, 2 to 3 hours into sleep, as blood glucose drops into hypoglycemia territory, the body releases cortisol and adrenaline to correct it. These are alerting hormones. They pull you from deep, slow-wave sleep, sometimes into full wakefulness, sometimes just enough to prevent the restorative stages where physical repair, immune function, and memory consolidation take place. You wake up having technically slept for 7 hours, feeling as though you did not rest. The meal you ate at 8 in the evening is still running a program inside you at 2 in the morning. This is the diagnostic signal most people never receive. The afternoon craving that arrives at the same time every day. The skin that has been slowly stiffening for years. The sleep that restores less than it should. These are not separate problems. How they are one process started by one combination, playing out across your entire body on a timeline most people never see. Sugar is not poison. Fat is not the enemy. Your body processes both separately, in the forms that whole foods deliver, with precision and efficiency developed over hundreds of thousands of years. What it was never built for is the combination, high sugar and high fat, arriving simultaneously in the concentrations that modern food engineering has made ordinary. That combination is not a treat. In a very real biological sense, it is a signal your body never evolved to receive. And it keeps sending responses through your dopamine, your gut, your collagen, your sleep, that you feel every single day without knowing what started them. Have you ever noticed a craving that arrives at exactly the same time every afternoon, or a restlessness at 2 in the morning you could never explain? Tell me about it in the comments below. I read every single one, and this community has some of the most honest conversations about food I have ever read. And if you want to understand what else is happening inside you at night, the process that runs while you are asleep and quietly shapes how you feel by morning, the next video is already waiting for you.